画面都看得到吗
有看到。
？OK OK. Uh, Hello everyone. This is Simon. I'm from PM team. I'm in charge of the AC source as well as the 1U type DC source. And today I will be giving the lesson for the AI server testing. As we know, this is the booming market as well as related to our revenue of Chroma. Originally, Sean will be participating the second part of the slides. Unfortunately, he is on a mission to customer. So therefore, I will be handling the whole section today. Okay. Okay, let's start with our AI market trends. So from the Bloomberg or from everywhere you can see, even the stock price of the Nasdaq, you can tell that the AI server market is one of the most booming market recently, especially these 2 years. And luckily, in this year, we can see the AI perpetual motion machines. Actually there is no perpetual motion machine invented yet, but however, the companies are investing huge amount of money on each other. It's like OpenAI is buying the servers from NVIDIA, and the Oracle is providing solutions to is also paying money to NVIDIA. So there it becomes a circle, and we can see that in recent years there are many more companies join this circle, such as Foxconn. They are the one of the main server supplier for NVIDIA as well. And they just announced that they are building a AI data center for their own, meaning that they are providing their products to NVIDIA, and somehow they are buying back from NVIDIA to build their own AI data centers. So the circle will become bigger and bigger. Okay, that's one of the interesting part that is happening this year. Okay, so since most of us are not really familiar with the AI servers, therefore this slide will shows how the voltage on convert from the grid to the AI chip all the way down. Okay, so on the very left, we have the three-phase, the grid system, maybe from 10 kV to 30 kV something. And then we have the step-down transformer, which is the very huge one. We convert it all the way down to single phase that we can see easily nowadays on the walls or in the factories, like 110 or 220 or 230 in Europe. But for the AI servers, they are running, so for the shifts, they are running in three phases. But however, each AI server, you can see the number of multiplied by 3. So each server power supply is running under single phase. And the rated voltage of the AC voltage for the server is stated at 200 to 277 VAC for each server power supplied. Of course, we are looking at something new already. The something new is called HVDC, is high voltage direct current. So we are looking at something new parameters such as the plus minus 400 volts or 800 volts. Even someone's mentioning about the plus minus, oh, it's 800 or 750 or even 1500. Okay, that's something new. We can just leave this in our mind first. Then we have the power supply, which with the AC input of maybe let's say 230, and then we convert it of the output to 48. And the next stage will be from 48 to 12, and then 12 to under 5 volts, all the way down to the CPU or GPUs. Okay, so that's the voltage conversions in the AI servers. There are many kinds of AI servers, so I categorized by myself This is not something that you have the 100% correct answer, but I categorize by myself. Okay, so we have these organizations such as OCP is called Open Compute Project, which is the one of the top non-profit organization who defines the specification for the AI servers. And of course, we have the NVIDIA. They are defining their own specification as well. And we have others like Intel, Murata, Sloan, GE, L-Tech, etc. They have their own server specifications. So I put them all at the side. So mainly, the main trend of the AI server I highlight in red is what we called ORV3 or plus minus 400 or NVIDIA proposed 800 volts. But you can also tell that plus minus 400, the combination is 800 as well. Okay, so in 2025, the main power trend of these servers for the ORV3, we have the 8.5, 10K, and 12K for each server power supply. If the shelf consists of 6 pieces, so you can multiply by 6. So each shelf is 72 kilowatt per shelf. And the plus minus 400 volts and the 800 volts are something really new. We don't really see the product is running in mass production yet, but however, all the manufacturers are dedicate in their resources on these two topics, and we are looking at uh, each power supply are running more than 20 kilowatt per unit. The CRPS, or now it calls MCRPS, they are more traditional. They do still exist in the market, and we are looking at the manufacturers are dedicates in around 2.5 and to 4.2 to 4.5 or 4.8 kilowatt per unit. But this is not the main trend. The main trend are in the red labels. Okay, so we have all these kind of servers. So today we will focus on the
1, 2, 3, 4,
ORV.
5.
Sorry? Okay, I'll just continue. Today we will focus on the ORV3 mainly, and then we have a little few slides for the HVDC, which is the plus minus 400 and 800 volts because it's happening right now. So mainly the ORV3, since it's a non-profit organization, the latest specification will be published on the Open Computer Project website, where you can find the specifications. If you log on their website, you can see there's a project, and if you click on the project, you will find a rack and power section. So then you enter in the section, you'll see there's a specification and designs. Click on that, you'll have like a Wikipedia page, and there are a lot of folders, and underneath there are a lot of files that is published in the past. So if you want the latest specification, here you can see the ORV3 system specification folder, or you have the Modbus, the PSU Modbus uh, documentations. So if you click into it, you'll find the latest specification in the folder. But um, but from time to time, you have to log in and to check if there are any revision change or not. So you need to check like maybe once in half a year or 3 months. Okay. If we have downloaded the specifications for the servers, we already pulled out the test that listed inside of the specification for the PSU label. So we have all these tests. They are commonly tests as regular power supply as well. And especially state that the peak power of the power supply, the maximum will be 160% for 400 microseconds. But most of our customer, they will test with even higher standard. Maybe they will test under 180% or even 200%. Okay, so the manufacturers or the customers will have their definition on their own too. So they want to make sure they are more than compliant to the minimum requirement of the specification. Why did I highlight the red color of this AC signal, AC loss signal? Because from time to time they will change the mechanism or the algorithm of the signals or the data sheets. So one of the latest changes that they changed the functionality of the AC loss signal. Okay, so here just to show the example that they have the revision change list, and you can look for the what they have been changed recently. Not only for the PSU label, but also for the shift label, they also state some of the test requirements that you can find in the specifications. And the peak load tests are basically the same. Okay, so by that you can find the minimum test requirement from the OCP website and inside the specifications. So these are the minimum you can find. But of course, the customer might they have their own preference of testing their products. Okay, let's talk a bit about the history change of the server power development. In the past, we starting from very low wattage, maybe it's a 3K, and we enter in the HBR, which calls a high power rack. So each unit is 5.5K watt per unit. And then we enter into HPR V2, it's a 12K unit. And the HRPR V3 actually they are not only change the wattage of the power supply, they also change the structure of the racks. So in the past, we have the PSU, BCU, BBU, GPU, CPU in the whole same rack. Then in the in the HPR V3, we have the PSU and BBU in a single rack, and we have the computing rack individually. The voltage in between will be 48 volts, but somehow it's just a way to call it. It's now 51 volts because they changed the algorithm. But either you call it 48, 50, or 51 is all good. But 48 is most commonly used. Since we pulled out the power supply and the battery backup unit into a single rack, we call it sidecar. So it's a car put at side. Okay. And then we enter in the HVDC, which is the plus minus 400 and 800 volts. Why do we do that? Because the wattage of the whole rack is increasing to right now we are looking at 900 kilowatt per rack. Okay, so in order to have the similar setup, we have to rise the voltage in order to lower the current. When you lower the current, you can lower the power loss by 4 times of your lesser. Okay. So the previous slide is from the electrical point of view, and this slide you can see from the mechanical point of view how it changes. In the past, on the left, we have everything put in the same rack and running under 50 volts. Okay. Then on the V3, we have the sidecar that is has been proposed. So you have the BPU and the power shelves are in the same rack, and then you have the IT, which is the computing rack at the side, and the transmit is still running at 50 volts. The next generation, which we will looking at 2026, is the HVDC. So it's still a sidecar idea, but they will transmit the voltage into high VDC. So the AC goes from the top to the A to D rack, and then we have the output of the 400 volts or even 800 volts, and we have the PDU to cover. We have the 800 volts to 50 volts shift converted to 50 volts, and then goes into the IT gears. Okay, so this is what we will see in the 2026. And the sidecar, I think most of the manufacturers are entering the mass production in 2025 for this kind of structure, and this will be the near future structure. Okay, so this is just to bring you the electricity changes inside by diagrams. So in the past we have the AC to 50 volts and then to the PDU and then all the way down to low voltage usage. And in 2026, we will see the plus minus 400 or even 800 volts and goes into the shifts. The shifts will convert to 50 volts and then the back end will be the same. So what everyone is trying to minimize uh, uh, the power loss. So how to minimize the power loss is to increase the voltage from 50 volts to all the way to 400 or 800 or even some of them is speaking of the 1500 volts. And what are the benefits? So the benefits that we have less wires. So let's say if you have the 800 volts, you only have two wires, the plus and the minus. All right, so you save a lot of copper on it. And by that, you also increased the efficiency, which means you lower the power lost. And another good part is that the payload racks also, so the premium space in the payload racks can be used for computing. So you have the side card, so you can put all the CPU, GPUs together since they are running and transmitting in very high frequency. So you don't want them to be separated. You want them to put it as close as possible. Okay. So here just another idea of the benefits of 48 racks and to the plus minus 400 distributions. And there's one, let's say, rumor saying that if you have we all know that the battery burns and it burns really, and the fire is not easy to put out. So and the CPU and GPUs are so expensive, so it's better to separate the dangerous stuffs from away from the very expensive CPU and GPUs. So that there's someone says that also. Yeah, so that brings another part for the safety part. Okay, so we went through the history of the ORV3, not only from the voltage rising from 50 volts to 800 volts. We also see the racks design are from everything integrated into one rack. Now we have the sidecar. So what Chroma equipment can fulfill or deliver to our customers for the ORV3 testing? Okay. Since we still have the 50 volts existing in the market and it's still the main trend, we collect some of the most difficult tests of our from our customers. And these tests are not, some of them are not really defined in the specification, which you can find on the website of the OCP, such as the dual channel synchronization, the inverse current, the ITIC. So these three tests are not defined in the specification of the ORV3. And this is for the AC side. DC side, the peak load is stated clearly as I already shown. The EDPP is actually required by the GPU testing. So this test is not defined in the specification of the ORV3 as well. Not only BBU, but capacitor backup units are also proposed recently because of the maximum peak load drawing by the CPU and GPUs. Okay, so we have the AC side testing challenges, we have the DC side testing challenges. Back to the fundamental. Each power supply are defined clearly in the OCP specification for the ORV3 that each power supply for 5.5 kilowatt will need to fulfill the DC current of the through rate 1 amps per microsecond. For the shelf is fixed to 6 unit maximum. So we multiply by 6. Then we are looking at the power racks, which is the side card. The power rack are now reaching 900 kilowatt and it's even scalable. So we are looking at around 900 kilowatt. So it's in total 163 amperes per microsecond. With all these test challenges and the through rate requirement, at Chroma we can use these products to fulfill the test for the PSU level and the shelf level. For the 61815, we have the high power density. And of course, some of the building, they cannot hold up the weight of the 618-100s because each of the 618-100 weighs around a ton. If your customer, they want to test a mega level, so so you need like 10 pieces of the 618-100, so the weight will be huge. So in some of the cases, we will recommend the customer to use the 615 because of this high power density, and the maximum we can reach is by 20 pieces in parallel, we can reach 300K. That will satisfy most of the shelf testing requirement. And another good part is that the shelves are running in 2 AC inlet because of the current limitation. One of the customer proposed that they want to do different voltage. They want to do 110 60 hertz on one AC input, and they want to do 230 50 hertz on the other AC input, but they want to run in the same sequence power line disturbance tests, such as AC dip or AC pulse. In this case, we will suggest the customer to use the 61815. So you have two groups of the 61815 to run the dual channel synchronization test. But anyhow, if you face this kind of requirement, you can reach to us. We have the slides ready for that. For customer, they want to run into a very huge wattage. They want to run more than 300K. Then we need to go to the 618-100. The maximum will be 1.5 mega VA. And with this H3 simulator, we can satisfy at the ITIC 500%. Okay, that's for the AC side. For the DC side, we have the high through rate, the 632.24A-150. So we can satisfy the through rate of the PSU and the shelves, and the maximum is 1.5 megawatt. But a customer, they might want to run in a certain like a long-term testing, like a ORT testing or burn tests. It will be recommended to use our 6371A series. It's a regen load, which is suitable for long-term DQ testing and for burn testing. So they can save more than 80% of their electricity bill. Okay. If we go to the power racks, of course, it's a very high power. Some may reach. We are looking at 900 per rack. So from the AC side, we'll recommend the 618-100. We can reach 1.5 mega now. And for the DC side, is the similar setup. So if you want a very fast slew rate, you can choose the linear one. If you want to have a long-term testing with electricity bill saving, you can choose our regen DC loads. As I mentioned that the voltage are rising from 50 volts to 4 plus minus 400 volts or even 800 volts. So we will face some of the customer. They might asking you about the HVDC testing. So basically, we for the high voltage volts, the loads because it's a DC only. So either it converts from AC to DC or it converts from DC to DC. So for the AC side, it's the same as previous slides. For the DC loads, we have the linear one, the 24A 1200 volts. So the maximum you can reach is 1200 volts. So the benefit of that is it's a very high through rate linear load, which can achieve 24 amps per microsecond. And as I mentioned, they might need to do a long time testing or burn-in test. We have the 62450D, which is a bi-directional DC source. So this product can act as a DC source or DC load, which up to 2000 volts VDC. That is will be satisfying most of the test demands or test voltage in the HVDC system that we're looking at nowadays. Here you see something new. It's called solid state transformer. And this is a very early stage. So I put it here just to let you know that this is something that we are looking at right now. If your customer asking for it, you can back to us. We will have further discussions. So this just to bring you an idea that the solid state transformer is related to the high HVDC testing requirements. And of course, we have the new product that is under development because we want a high through rate and a regen together. So there will be something new in the near future. The customers to when the customer they are developing AI servers, they may not only developing the AC to DC segment, they might also have the DC-DC segment in their department or their department behind them. Okay, so I'm bringing some of the products that might be used in the DC-DC segment of the AI service. So we have the HVDC to 50 volts, and we have the 50 volts to 12 volts test solutions. Here is the block diagram shows that in the future we have the 800 volts to 50 and 50 to even lower and lower. Okay, so it's the similar stuff as I mentioned. And the customer are requesting the profile, the loading profile will be look similar like this. So they're requesting at least 10 ampere per microsecond. That will be their minimum request. And this segment will propose our 63224A and 63600 series. So we have the 24A series, which I already showed in the previous slide. The maximum voltage we can reach is 1200 volts. So we can fulfill the 24K 800 volts or 55 volts at 24 amps per microsecond. So, right? So with this model, you can fulfill high voltage and low voltage together. But of course, if the customer want to run like a mega VA label, but only low voltage only, you can propose the 150 volts model. So it has higher current. And for the even faster through rate, we could propose the 63600. series. It can reach 2.4 kW at 48 amperes per microsecond. That will be uh two that will be five modules in total of 2.4 kilowatt. And of course, for the higher wattage, we need to use the 63224A series to fulfill the megawatt label testing. Okay, so you have a smaller DC to DC below 2.4K. You can propose the 63600 series, and for a higher wattage, you can propose the 63 224A series for higher wattage testing. And let's go to a even lower voltage of the AI server system. If we go to the lowest, we can see maybe 3 volts, 5 volts, or even lower than 1 volts. Those are for CPU and GPUs. So the picture on the left, you can see in the past, if you want to have a huge current, maybe 1,000 to 1,000 amps for the CPU and GPUs, you need to connect a lot of wires to distribute the current sharing because the current is too huge, so you need a lot of wires to do so. Therefore, we propose a new product that is the 63202A-20-1000. So it's a 20 volts maximum with 1000 amperes or 2000 amperes. The lowest, it's rated that you can draw 2000 amps at 0.25 volts. So you can see the graph here. You can draw 2000 amps at 0.25 volts. What happens if the voltage goes lower, maybe to 50%, to 0.125? You can still draw 1000 amps out of it. So it doesn't mean that our machine will stop working if the voltage goes below 0.25. So please remember that. And particularly for this model, we designed the bus bar in the front of the machines. In the past, we have our output bus bar in the back of the machines. So the customer, either they have their long cable from the back to the front, and so they can connect to their DUTs, or either they have their own bus bar fixtures. I have visited one of the customer, they designed their own bus bars and connected from the back to the front and doing their own fixtures in the front of the equipment. So this generation, we designed a bus bar in the front so we can shorten the wires. What are the benefits of shorten the wires? So we can decrease the power loss of the wires itself, and we can lower the inductance by shortening the wires. So there are two benefits of it. On the top of that, Chroma also have patterned low inductance wire. Compared to the traditional wire, we can lower 60% of the inductance. So the customer will face lower overshoot of the current during the test. So with all this designed, the front end bus bar, the pattern wire, low inductance wire, we are helping customer to minimize the effect of the inductance of the wire that cause trouble when they testing. Okay, so we finished all the voltage from the 50 volts to HVDC and down to 12 volt or even the CPU, GPU label. And let's look at some of the test equipment list when customer is talking about the mega level testing. It shows that it's a 900 kilowatt DUT. And it's sort of traditional. It's a AC to 50 volts DC application. In this scenario, we have the 618-100 12 pieces. Since there will be a lot of wires, so we have this AC port. It's like a rack with a lot of bus bars and screws. So the customers can connect the wires into the AC port to make the wiring more lean, so you won't have a messy wired. And then we could connect the AC to the DUT, and we have two kinds of DC loads that they can choose. For the fast through rate, we want to perform the testing. We can choose the 63224A 150. Of course, we have the 1201, but here, since they are only running on low voltage, so we choose the 150 version, the product, so we can have a higher current. We can choose 15 pieces of the racks, the products. If you, but in this way, they can do the fast performance testing, but the energy will basically just burn out into the air. So the chamber will be super hot. If they want to do a long-term testing, maybe they want to run for an hours or days, even months, it will be recommended to use our regen load. By doing so, the energy drawing from the DUT will be regenerated back to the grid. So it can be reused by the machines or other equipment in the factory. Okay. Since there are a lot of energy running in this kind of situation, so there are two things that needs to be paid attention of is that the total CFM means the airflow must be satisfied to fulfill the heat dissipation of all these machines. Another thing is the weight. So you can see how much weight. It weighs 26 tons for all these machines. So the floor of the building must be very robust in order to hold all the weight of this mega level testing. And we have the next slide for the HVDC one. So for the AC side, it's the same, but the DC output will now become plus minus 400 or 800 volts. In this case, you can choose the 62450D-200 is a 2000 volts bidirectional DC sources, and you can also add as a regen DC load. So you can have this over here to regen the energy back to the grid to save the more than 80% of the electricity bill. Or else you can use the one that we previously mentioned, the linear loads, but since it's a high voltage application here, so you need to choose the 1200 volts one, the version, and the regen load. So you can either implement the loads right over here or right over here. It's both workable. But we also do have the 400 volts to 50 volts. So there are 3 units that you can configure according to customer's preference, but we put everything here. So for the linear load, its energy are 100% dissipated into the heat to the air, and we have these two models that we can regen the energy back to the grid. And so by different scenario or how customer wants to test the units differently, we have different products that could be proposed to customer. And as I mentioned, the total CFM and the total weight of the machines must be paid attention. And some of the notes are underneath. You can read it when you have your own time. I won't go through all the details. So here, just to give you some idea, the main picture to you. So when customer ask for mega level testing, you can pull out this page and to see what solutions we can provide. Next part, I'll bring some specific case to show you. Okay. So we have doing the mega level testing. I would say because for the 618-100 in the specification, we only defines that we can parallel up to 8 pieces. But now due to the AI server demand, we had some cases we ran already. So we had the 1.26 mega VA testing and even 1.57 mega VA testing in the headquarters. So you can see there are many units of the 618-100. Some of them are acting as source, some of them are acting as loads. So we test each phase, we test each phase individually because we weren't able to set up, let's say for the 1.5 mega, we need 30 pieces of the 618 100 if you want to do a total testing, but we are not able to get that kind of quantity of machines, or we need a lot of space to do so. So we test uh, each phase individually. Okay. And the next will be the loads. Chroma not only provides the product, but also we can do the system integration for the customers. I mentioned about the testing wire distance that will affect the inductance, which will cause trouble to customer during the testing. If you go into a higher current, the effect will become higher. Therefore, by doing this kind of system integration, we can replace the wire connection to bus bar. And Chroma have our own patent low inductance bus bar design for our loads. The picture that you are looking at is 1.4 megawatt DC loads with bus bar. Okay, so it's 60 pieces of 24K units in total. And if you see, if you have the higher inductance, the current overshoot will be higher. If you have a lower inductance, the current will be smoother. That's how the inductance affect during the test. And of course, none of the customer will be looking for this kind of waveform. So this is one of our Chroma's benefit. We can do the integration for the customer, and we have our low inductance bus bar. There's a side story that one of the customers, they did their bus bar on their own, but eventually caused a lot of trouble during the testing. And we found out the inductance of the bus bar that they designed are a little way too high compared to Chroma's design. So eventually, I think uh, they they re actually redo the bus bar by Chroma's help. And the heat dissipation is one of the very crucial stuff as well. So Chroma also provides thermal simulation for customers. We have the site, uh, the graph of the site. We have the machines that are in place, so we can ask the thermal engineers to run the thermal heat dissipate simulation to see. Here we have the plot A and plot B. Actually, is in different height. So plot A is like 120 centimeters above ground, and plot B is like 30 centimeters above ground. So you can see the heat are accumulated in different regions or even in different heights. Therefore, we can provide some suggestions to the customers to maybe they need to open up some windows over here or even some over there to make sure that the heat won't be intercirculated, and that will cause the machine keeps shutting down by the over temperature protection, because that really did happen to one of our customers. So that's the main reason we always, um, let's say, keep reminding the customers of the heat dissipation is very essential to our machines. And if the temperature goes higher than the rated, then the fan or the airflow isn't enough, we have to derating our machines to a lower wattage in order to prevent from shutting down. We also do have parameters for that, but that's not a good chart if you really need to look at it. Now, if you want the chart, means you already have problem with the heat dissipation or the airflow. So in the very early stage, we want to make sure that everything is under control and we'll consider it. Okay, that will be all of my slides for today. And I think it's right now for QA.
Hello.
Yes, you have shown from the DC load. Hello, morning. This is Bose here. See, you have shown from the DC load stage, from where DC load you are sending it back to the grid. So grid is the AC, no? 63224 series.
No,
Yeah,
is there
from
any
from the DC load.
specified pages that you point out?
Yes, this screen. Yes.
So not all DC loads can regen the energy back. You need to choose the one with
Okay.
regen load, which is the 63718 series or either 62450D series.
Hello, Bosie.
Yeah, thank you.
Yeah. Okay. Simon, could you back to the page 9? Uh, okay. So he mentioned about down below 136%, 160, 100%. And this is talking about some kind of pulse loading. Am I right?
Yes, that's correct.
Okay, and behind the percentage, this is 50 milliseconds, 400 microseconds, and 1 second, either small, higher or lower length. This is talking about the time period to complete a cycle of loading. Am I right?
Yes, you can see the uh, blue graph on the left. So here's the amplitude. The amplitude is the percentage, and the duration will be the time scale that they requested.
Okay, understood. And the page 11. Okay, the right size, that's a GPU, CPU. This is about exactly AI server. I mean, maybe some kind of rack, or some kind of devices, right? That because the power supported by a power rack, left side 48 volts.
Yes, the 48 volts will goes into the computing rack. But of course, the
Okay.
48 volts still need to go down to 12 and then to 5 or even lower to 1. There are still DC-DC converters in the computing racks. Like a
Okay.
motherboard, if you have the motherboards, they are still like from 12 to 5 or even lower on the motherboard of the CPU GPUs.
Okay, and for this one, HPR V3 and V volts, V volt, and is the kind of because simply we divide by two kind of a system. One is ORV3, one is HVDC. So whether these three structures dedicated for ORV3 and or HVDC because if you see the down below V volt, V volt, that's plus minus 400 volt and 800 volts. So so it means I could define this is the HVDC structure, right?
Yes. For the voltage
And
up above 48, we could call it HVDC at this moment.
okay, and how about V3?
V3 because it's still running at 48 volts. So yeah, so it's
So can I consider it's kind of ORV3?
yes.
Okay, understood. And page 13. Yeah, page 13. Okay, whatever you mentioned about the computing rack, it means is the IT rack, correct? IT rack.
Yes.
Okay, so what about in between? That's a green block because you also mentioned about 50 volt, 48 volt, divert to 1 volt, 3 volt, 3.3 and 5 volts. So what we call about this green block?
The green block is actually it will be in the CP. Let's say the green never changed, right? There's a PDB,
Mhm.
so will be mainly really close to the motherboard. So this part haven't changed until today and still, or even for the near future. But what we are changing is on the left side. So on the top, the DUT, the ACE, the power supplies, and the BBU are pulled out to a single rack. Okay,
Uh,
but since there's a voltage changed, so you need to add the 400 volts to 50 because in the past because on the left you never change, it's still 50 volts. So you need to add
uh,
something to convert from the plus minus 400 for the rack on the left and to convert it to the 50 volts so you can be used by the green blocks.
okay, so could I consider the green block is some kind of embedded motherboard inside the IT rack?
Yes, that's correct. So I'll call this blue. So the DUT2 you see here, this is around 1 to 2 shelves only in the whole rack. So the green one, you can look at there are maybe 10 or 20 IT racks, IT shelves for the green.
Okay, understood. And page 17. Okay, page 17. Um, okay, I think you've answered my question already. Okay, and page 21. Okay, so here is talking about okay if now can I consider if now if we are going to test the performance of the power rack or the shafts or PSU, then due to the concern of slew rate, then we select the 63224A linear DC load. And
Yes.
if today, if um, the customer is going to do the reliability test, okay, so at this moment, then we suggest the regenerative because it can be saving the power. But however, slew rate might not be a concern during the reliability test. Am I right?
Yes, that's correct.
And page 27. Okay. Yeah, here mostly we saw people how they describe the HVDC is either plus minus 400 and 800 volts. But the actual application for the connection, whether there's any difference or they just consider the voltage gap and doing the same doing the same same connection.
For the plus minus 400, there's three wires for that, and for the 800, you have only two wires. So it's the positive and the negative. Because for the plus minus 400, you have the positive negative for plus 400, and then you have the neutral negative to a negative 400 for the minus 400. So it's three wires in total. But in this page, we are not going into that detail because we are just bringing a general idea of what are the products that we can provide under these circumstances, especially for the HVDC testings.
Okay. Okay. So have we ever encountered plus minus 400 volt case before?
What do you mean by before?
I mean, okay. So customer is I mean the user exactly he just want the three wires connection, and we also support them because if purely for 800 volt, it might be plus minus, right?
Yeah.
So it means if there are three wires, so suppose we have to consider some maybe switch matrix or else.
Yeah. For the plus minus, we have actually it's a slide prepared by Eddie Joe. Okay,
Okay.
he has the 62450D with configuration with a neutral minus to form a plus minus 400 testing solution for customers. Yeah, we do have customer asking for that. I
Okay.
think that will be your question.
Okay. Okay. Fine. And okay, I'm fine over here.
Okay,
Thank you.
welcome. So, uh, anyone with
And
any else?
hi, Simon.
Oh,
I have a
yes,
question on page 21.
21. Yes.
Yeah, regarding the hybrid equipment e-load, can we still use it as a DC source without removing in the system?
That is, I couldn't answer that at this moment.
No, you have to use that DC source and linear load together.
Yeah. I mean, that is for the load function, right? Like for in the future, the customer have a requirement for the DC source only. Can we still use it as a DC source without removing in the rack in the
No,
system?
no. If you want to use it as as a DC source, you have to remove the DC source out. But this is a system, load system, region load system, you know. If you remove the DC source out of the rack, I think that would be not a system anymore. So we could not guarantee any the hybrid load about the hybrid load. You know what I mean? You cannot remove all the equipment out of the rack, and you also cannot use the DC load as a DC source. I mean 62450D. Anyway, the 62450D always load here. No more DC source
Okay.
function. Okay.
Okay.
Okay. So I guess that will be all for today. Of course, this section has been recorded, and we will see how we could share to each other. If you have any doubts that you can went through the video again, and of course, you have any questions, you can reach to us for further assistance. I'll thank you all for your time, and class is dismissed. Okay, thank you.
Thank you.
Thank you. Thank you, Simon.
Thank you.
Thank you all.